PharmaPal.
Phytochemical Analysis of Anastatica Hierochuntica. Welcome to our exploration of the fascinating world of plant-derived compounds. In this video, we delve into the phytochemical analysis of Anastatica hierochuntica and Hierochuntica, two resilient plants thriving in the harsh desert environment of Qatar. We'll uncover their antibacterial and antioxidant activities, and reveal how these plants could be potential sources of new therapeutic agents. Join us as we journey through this exciting research's methods, results, and implications. Have you ever wondered how plants can survive in extreme conditions and still offer medicinal benefits? This video introduces you to two remarkable plants, Anastatica hierochuntica and Hierochuntica. These plants are not just survivors but treasure troves of bioactive compounds. Our study investigates their phytochemical properties and biological activities, shedding light on their potential use in traditional medicine. To extract the beneficial compounds, we employed the Soxhlet extraction method using various solvents, including acetone, butanol, ethanol, ethyl acetate, methanol, dichloromethane, hexane. We allowed the solvent to percolate through the Soxhlet apparatus for at least 10 cycles, typically taking 10 to 12 hours. The resulting extracts were concentrated to 10 mg per milliliter using a rotovap and stored at -20 degrees Celsius for further analysis. Phytochemical analysis. We conducted a thorough phytochemical analysis to identify key compounds such as alkaloids, glycosides, tannins, flavonoids, terpenoids, saponins. These analyses were crucial for understanding the therapeutic potential of the extracts. Antibacterial activity tests. To evaluate the antibacterial properties, we used the disc diffusion method, comparing our extracts against standard antibiotics like ampicillin and chloramphenicol. We tested various concentrations of the extracts and measured the zone of inhibition in millimeters. DPPH in vitro assay. For antioxidant activity, we employed the DPPH assay, adjusting extract concentrations and comparing them to standard antioxidants like alpha-tocopherol and ascorbic acid. The absorbance was measured at 517 nanometers to determine the inhibition percentage. Our results were quite revealing. The phytochemical screening confirmed the presence of various secondary metabolites in both plants. Notably, the extracts exhibited significant antibacterial activity against both gram-positive and gram-negative bacteria. The IC50 values for antioxidant activity indicated that the ethanol extracts were the most potent, while methanol extracts showed the least activity. The findings highlight the medicinal potential of Anastatica hierochuntica and Hierochuntica. Despite Qatar's challenging climatic conditions, these plants thrive and offer a wealth of bioactive compounds. The presence of various phytochemicals suggests they could serve as valuable resources for developing new drugs. Moreover, the antibacterial and antioxidant activities observed in our study underscore the importance of preserving these indigenous plants. As the demand for natural products increases, these plants could lead to new therapeutic agents that benefit both local communities and the broader pharmaceutical industry. Identification and characterization of active compounds. In the study, researchers employed advanced techniques to isolate and characterize the active compounds from Anastatica hierochuntica. They used preparative HPTLC. This method involved a CAMIG HPTLC scanner 3, utilizing a solvent mixture of hexane and ethyl acetate in a 7:3 ratio. HPLC, the high-performance liquid chromatography, was performed on a Shimadzu SPD-20A HPLC instrument with AC-18 column. The solvent system consisted of acetonitrile and water in a 15 hours 85 minutes ratio, with a flow rate of 1 milliliter per minute. The researchers recorded UV spectra using a PDA detector, and further characterization was done using IR and NMR spectroscopy. HPTLC, a technique used for separating and analyzing compounds in a mixture. HPLC, a method for separating, identifying, and quantifying components in a mixture. NMR spectroscopy, used to determine the structure of organic compounds by analyzing the magnetic properties of atomic nuclei. Phytochemical screening. The phytochemical screening revealed a variety of secondary metabolites present in Anastatica hierochuntica. These include alkaloids, glycosides, tannins, flavonoids, terpenoids, saponins, phenols, anthraquinones, antibacterial and antifungal activity. The study also evaluated the antibacterial and antifungal activities of isolated compounds from Anastatica hierochuntica. The compounds were tested against various bacterial strains, including E. coli and S. aureus. What are the key secondary metabolites identified in Anastatica hierochuntica, and what biological activities are they associated with? The study identifies several key secondary metabolites from Anastatica hierochuntica, including beta-sitosterol, campesterol, methyl 9-4-3,4-dihydroxy-1-methyl-5-oxocyclohexyl-2-hydroxycyclohexyl, nonanoate. These compounds are linked to various biological activities. Antibacterial, effective against E. coli and S. aureus. Anti-inflammatory, campesterol has been noted for its traditional use in treating menstrual cramps. Antioxidant, contributes to the overall antioxidant potential of the plant extracts. How does the antibacterial activity of the isolated compounds from Anastatica hierochuntica compare to that of standard antibiotics like chloramphenicol? The antibacterial activity of isolated compounds such as beta-sitosterol, campesterol, and methyl 9-4-3,4-dihydroxy-1-methyl-5-oxocyclohexyl 2-hydroxycyclohexyl nonanoate was evaluated at a concentration of 2000 g/ml. The results were compared to chloramphenicol at 200 g/ml. While the isolated compounds exhibited some antibacterial activity, their effectiveness was generally weaker than that of chloramphenicol, indicating that further optimization or combination with other compounds may be necessary for enhanced efficacy. What methodologies were employed to isolate and characterize the active compounds from Anastatica hierochuntica? The active compounds were isolated and characterized using preparative HPTLC, high-performance thin-layer chromatography. This technique was used to separate compounds based on their polarity. HPLC, high-performance liquid chromatography. Further purification of the extracts was achieved using a C18 column with acetonitrile and water as solvents. Spectroscopic techniques. NMR, nuclear magnetic resonance utilized for structural elucidation, with spectra recorded on a Bruker 400 MHz spectrometer. IR, infrared spectroscopy conducted to identify functional groups within the compounds. Discuss the significance of the environmental conditions of Qatar on the phytochemical composition of Anastatica hierochuntica. The unique desert environment of Qatar, characterized by heavily weathered soil and extreme climatic conditions, significantly influences the phytochemical composition of Anastatica hierochuntica. Plants growing in such harsh conditions often develop specialized metabolites as a defense mechanism against environmental stressors, such as drought and high salinity. This study highlights that the limited vegetation in Qatar necessitates the exploration of local plants for their potential therapeutic properties, as they may contain unique compounds not found in flora from more temperate regions. What are the implications of the findings on the potential therapeutic uses of Anastatica hierochuntica and Erva javanica? The findings suggest that both Anastatica hierochuntica and Erva javanica are promising sources of phytomedicines, with potential applications in antimicrobial treatments. Their extracts demonstrate antibacterial and antifungal activities, indicating possible use in treating infections. Antioxidant therapies. The antioxidant properties of the extracts could be beneficial in preventing oxidative stress-related diseases. Traditional medicine. The study supports the traditional uses of these plants, providing scientific backing for their incorporation into modern therapeutic practices. If you found this information helpful, don't forget to like, subscribe, and hit the notification bell for more insights into the world of medicinal plants. Thank you for watching, and see you in the next video.
PharmaPal.